I'm Alan Johnson, KU2Y, and this is a CubeSatSim assembly video. This is step 4.2, continuing to build the main board. So we have our main board that we built in step 1, and we tested it in step 4.1, and now we are continuing. So I have the wiki instructions from GitHub on my phone. I also have the bill of materials set to the by step tab, and that way I can see the parts as I need them. For example, main board from step 1, so I can check that to say that I have it. Okay, so in addition to the components here, we need some tools. I need my soldering iron, metal curls, or a sponge for cleaning the soldering iron tip, some blue putty for holding parts in place, solder, side cutters, and pliers as well. Okay, so let's get started. The first set of components we need are for the audio filter. So for that we have 2 capacitors and 2 resistors. And the resistors again are going to be vertically mounted. So I'm going to bend them over like so. Okay, so we have capacitor C5, which is a 47 microfarad electrolytic capacitor, kind of looks like a can. A 100 nanofarad capacitor C6, that's the small yellow one. We have a 220 ohm resistor, that's this one here. R20, color bands are red, red, brown. And a 100 ohm resistor R19 with color bands brown, black, brown. Okay, so the electrolytic capacitor has a polarity, just like diodes have a polarity. And if you look on the circuit board, there is a plus here. Here is C5, is this component here. And you see a little plus there, indicates that the positive lead should be down. And if we look at the capacitor itself, one pin is labeled with a minus. See how it's white and there's a minus there. Also, the other pin, the positive pin, is longer, just like there was a longer pin on the diode. So I'm going to install it here on the top of the board, and I'm going to put the longer pin towards the bottom, going through the plus. So it goes in like so. So you see the white minus sign here is pointing towards the top of the board where the GPIO connector and the switch is. Okay, now we need the 100 ohm resistor to go right there. We need the 100 nanofarad capacitor, goes next to it there, and the 220 ohm resistor goes here. Okay, so there's those 4 components inserted, and I'm just going to put a little bit of blue putty over them here, try to keep them in place. And if we look underneath here, we want to spread the pins just to get a little bit of mechanical strength. Okay, so you see how I bent the pins there? All right, so now I'm going to solder just one pin on each component and then double check to make sure that the part is straight and with the correct polarity. Okay. That. Now take off the blue putty, all the parts, double check the polarity of the capacitor, make sure the negative is pointing up. Okay, that looks good. So I'm going to go ahead and solder the other pin on each of the components. Okay, and now I'm going to trim them. I have my safety glasses on, and also I'm going to just put a finger on each pin as I cut it so it doesn't go flying. There we go. Let's have a look. Looks good. I don't see any bridges or anything. Everything looks good. Okay, now we're going to mount the female sockets that are used for mounting the Raspberry Pi Pico. So this is the Pico that you would have programmed in step 2. So it's going to plug into it. So we're going to insert these. So this is J2 and J3. They're female 20-pin sockets. And I'm going to use the blue putty here to hold them in place so they don't fall out. Just going to do it on the inside of them. Now, it's extremely important that these are spaced correctly and that they're angled correctly. Like right now, you can clearly see that's not good. See the angle they're on? If we soldered them in like that, this would not plug in. So instead, we need to carefully space them. We can either use a pin header, or you can actually use the Pico itself if we just do it at right angles here. So if I put it in here like this and just press it down, that's doing two things. It's spacing them correctly, and it's also making them at right angles. So that there, I just make sure they're held in, make sure they're pushed in all the way. And if you look, you can just see the pins are poking through. Now I'm going to solder one pin on each of them. And then I'm going to take a look. Make sure it's straight. Make sure they're plugged in all the way. There's no gap. Looks good. Now I'm going to do one pin on the opposite side. And again, just go through it really carefully to make sure everything looks good. Okay, that looks good. So now I can go through and solder all of the pins. And you just want a nice teardrop shape on each of them. No bridging. And also we don't want to see any of the hole exposed. keep the tip of my iron nice and clean so it's shiny. Now do the other one. Okay, let's just inspect, make sure there's no bridges. Looks good. Now we can unplug Pico and take out the blue putty. Very good. Okay, so now let's do some testing here. Now that we have these components in here, which is an audio filter, we can test the FM modes. So to do that, we need our Pi 02, we need our micro SD card, and we also need our USB-C cable powered up. So let's flip the board upside down, make sure the micro SD card is installed in the Pi 02. Carefully plug it into the bottom here. Okay, so now we are ready to go. So I have my HT turned on, so we should hear it. We see the red power charging light come on and see the green LED on the Pi 02 start to blink. We should see the green power LED come on there, indicating the software is running, and the blue. Don't know why that went off. I think it just rebooted for some reason. So the green power LED will come on again, and then the blue. Here we go. All right, we hear the CWID. Okay, so it's going to come up in the same mode we were in before, which was BPSK, that buzzing sound. So I'm going to use the push button to change to one of the FM modes. I'm going to do SSTV. So we should switch it to that mode in a minute here. Okay, so you hear the BPSK. So now I'm going to push and hold the push button. The green power LED is going to start blinking. When it blinks 4 times, I'm going to release it to put it into SSTV mode. So press, hold, 1, 2, 3, 4, release. And there we go, it is rebooting. And then we should again hear the CWID, and then we should hear the sound of slow scan TV. Okay. There we go. So that is the sound of slow scan TV. So that shows that our FM transmitter is working, and that our audio filter is working as well. Very good. Okay, so I'm going to shut down the Pi again by pressing and holding the button. It's going to go through a whole sequence of blinks, and then when it blinks slowly, I'm going to release it. So press and hold, going through the whole sequence. In this case, all 7 modes. Now it blinks slowly, and so I release it. And I wait for the blinking to stop on Pi 0. Very good. Okay, so I am all set now. And I'm going to unplug the Pi 0 and continue our build. So next we're going to do the two 4.7K resistors, R23 and R24. Here they are. They are, the color bands on them are yellow, violet, red. Go. And put them here. Here's R23. Here's R24. Again, it does not matter which way you put them, since they have no polarity. Okay. Looks good. Okay, so that's those two resistors. Okay, so now we're going to do the two sensors. So there is a BME 280 sensor, which is this small purple one. This does pressure, temperature, altitude, and humidity. And there is also a MPU 6050, which is a gyro or an accelerometer. So here it is here. It's this larger blue board. And each of them has a pin header, in this case a 4-pin pin header and an 8-pin. With the blue accelerometer one, you might have a right angle pin header in your package, in which case you just you don't need that part there. Now they can be plugged directly in with the pin headers. You could just put the pin header in here and solder it in permanently. I usually like to use sockets for them, but it's up to you. So here is a 8-pin female socket and a 4-pin female socket here. That way the sensors can be removed. So that's how I'm going to do them. So first I'm going to solder the female sockets on. And I'm going to use the blue putty to hold them in place. And I want to look to make sure that it's plugged in all the way, that there's no gap. And also you want to look to see that it's at right angles, that it's not tilted. So here, this one, you can see there's a bit of a gap there. So I'm just going to push that in. That's better. And then we check the angle here. Just make sure it's roughly at right angles there. That looks pretty good. Okay. So I'm going to solder one pin on each. Okay, now take a look, make sure it's plugged in all the way. See, that popped out just a tiny bit. So I'm just going to heat up that pin and push down on it. Here we go, that's a little better. It's also tilted slightly too. Fix that as well. There we go. Better, okay. So now I can solder the remainder of the pins. Oops, look at that, I accidentally bridged those two pins. Do you see how they're bridged together? So, could use wick to remove it, but I can just heat it up. Heat up both pins, and then remove it. There we go. Let's look here. Looks good. Looks good too. Okay. So, we can remove the blue putty. Okay, so now I'm going to take the pin header, and there's a short side and a long side. So the long side is the one that plugs in into the socket. So I'm going to put it in like this, long side down, push it in, and then this is going to sit on top like that. So let me do him first. Let's do one pin. And now we can do all the rest. Oops. Okay. So that's good for him, and you can see how we can unplug it and plug it in. Okay. So I'm going to do the same thing for the BME sensor here. U3. So I'm going to put the long side of the pins go into the socket. I'm going to put it down. Now, with the blue MPU 6050, only one side had components. You can see components here, and then this bottom side is just blank. So it's pretty obvious how that one goes. This BME sensor, though, it has components on both sides. And if you're not careful, you can solder it upside down. So there's two hints. One is that one side has has this hole in it, circular hole, and you see how the circular hole is drawn on the silk screen of the PCB, and you see that it's on the bottom side. So that tells you that it's going to go like this. Right? If we have it upside down, see how the hole is towards the top. So that's one thing. The other thing is that the sensor itself is this tiny little square can on it. So the sensor always points up. So if you flip it over here, there's just components, resistors, capacitors, things like that. The actual metal can sensor is always on the top. So that tells me that it's going to go like this. And I don't really want to solder it tilted like that. See how that's angled? So I'm going to try to just hold it. Like that. Okay, so I'm just double checking that I have it up the right way. The hole is down, and the little square metal can sensor is on the top of the board. So that looks good. So I'm going to go ahead and solder the remaining pins. Okay, so there we have it, the BME 280 and the MPU 6050 sensors installed on the main board. Okay, so we have a couple more components here. We have a 100 nanofarad capacitor, this little yellow one. We have a 10K resistor. So 10K resistor is brown, black, orange. And I'm going to bend him there. We have a diode, a 1N5817, so similar to the other diodes that we've used. And it is D2. So you see D2 is right here. And the polarity is such that the silver stripe, the band, is on the left side here. So it's going to go like this. That matches the schematic symbol there. So just like before, I'm going to bend it over so that the stripe is pointing up. That way all my diodes are the same. It's there. And now there's one other diode, which is a 1N4148 diode. This diode looks different, as you see here. It basically, instead of being black plastic, it's actually glass. So you can see through it. And instead of a gray band, it has a black band, but otherwise it's the same. It's slightly smaller too. So here it is there. And it is diode D3. And D3 actually points the other way. So this is D3 here. So the band should be on the left. So it's going to get installed like this. Okay. So again, I'm going to bend it so that the band is sticking up, is at the top. Okay. So those are my four components. So let's do the 10K resistor is R27. Doesn't matter which way it goes. C9, the 100 nanofarad capacitor, also doesn't matter which way it goes. Goes in there. Next I'll do diode D3, which is this glass see-through diode here. And I want the band to be on the right, so I want the band at the top here, like that. And then finally, D2, which is the black plastic diode, goes the other way. Okay, so you see all four of those components there. And now I'm going to bend the leads. Okay, and I'm also just going to put on a little blue putty here. just to hopefully keep them all in place there. All right, solder one pin. Okay. Have a look. Last chance to get the polarity correct on the two diodes. Looks good. All right, so I'm going to solder the second pin on each. And carefully trim leads. Oops, that one flew. And also, you don't want any of these offcuts sitting on the board like this, because they would short things out when you powered it up. Okay, so let's have a look. Okay, looks good. And then look at them there. Looks good as well. Okay, so now we're going to put the JST connector on, which are down here. And there's actually two of them. They're both wired in parallel, so they're identical. I'm just going to put in J7, which is the one labeled solar here. If your JST connector, when you plug it in, if it hear that click in and hold in, then you're good. If it doesn't, if it just slides in loose, you might want to put a little drop of super glue gel or some adhesive to give it a little extra strength there. Also, make sure, see how it has a slot? The slot should be facing the edge of the board. Otherwise, the polarity will be wrong. Okay, that looks good. And again, if you put the wrong one in, it doesn't matter. They're both identical. Okay. All right, now we just have two LEDs to do here on the side, LED 1 and LED 2. So let's do LED 2 first. So let's see, LED 2. LED 2 is the white LED. So here it is. And we need a 1K ohm resistor, R30. Okay. And again, we'll bend him. Okay. And just like when we put in these three LEDs, we need to get the polarity correct. One pin on the LED is longer. That is the positive side. The positive is facing away from the edge of the board. So I'm going to take the longer pin here and put it there. This is LED 2, so it's this top one. In like that. And our 30 here does not have a polarity. Put it in like that. Notice that the white LED, it looks slightly yellow when you look at it. And I just need to bend the leads. Hold in place with some putty. Solder one pin on each. Double check the polarity. Note the flat side on the lens is next to the board. Looks good. Okay. Okay. All right, so let's do the yellow LED 1 and also a 1K resistor. $1K resistor R29 and our yellow LED 2. Oh, sorry, LED 1. Again, the positive longer one goes away from the board like that. And R29 goes there. Double check the polarity. The flat side is facing the edge of the board. Looks good. Okay. Very good. All right, now we have the quick connector, which is used for adding additional sensors if you want. Find it here. Here is the pin header for it. And here it is here. It's this little red board. It's going to go over here. I'm going to take, with the pin header here, the longer pins are going to go down into it like that. And then I'm going to put a little bit of blue putty here. Like that. And there's basically two ways you could put it. If you put it this way, hopefully you can see that that's not correct, that it doesn't line up well with the outline. also the pin labels are incorrect, whereas this is the correct way here, like that. Okay, so I'm going to solder these pins. I'm being careful not to touch the black connectors because they're plastic and they will melt if I accidentally hit them with the soldering iron. Okay, so that's soldered there. Now I need to flip it upside down and solder these pins. I'll just do one pin first, check on it. Looks pretty good. Okay. And you can trim these if you want, but you don't have to. There's nothing, they're not going to hit anything. Sometimes it can be a little difficult to get this blue putty out from underneath. Okay. And finally, we want to put the 2.5 millimeter audio jack, J13 here. So it's going to go in the left slot here, like so. And put some blue putty here to hold it in place. These pins don't stick through very much. Looks good. Okay. All right. So the next step is to install the antennas, and I'm going to do the SMA antennas. You could also do the tape measure antennas. You can take a look at how those are done on the wiki. But for the rubber duck antennas with the SMA connectors, we just need to solder those on. So I'm going to put them here on the top and put a bit of blue putty next to it. It's fairly important these are straight since they're things are going to screw into them. That looks pretty good. Sometimes you need to put a drop of liquid flux because these can be a little hard to solder. They also take a fair bit of heat and solder. But I'm just going to do one pin on each to start off. Double check, make sure that they're fully inserted and that they're straight. Okay, it looks good. Now I can solder the remaining pins. Center one especially takes quite a bit of heat and solder. Okay, so if we have a look at that, solder looks pretty good. Okay, and to attach the antennas with this, we would use the two SMA coax here. So you basically put one here and one there. And then the antennas themselves here would, of course, these will actually get mounted through the frame. So I'm just putting them on temporarily for the testing in the next section. Okay, so they are ready. And now we can plug the Pico in and make sure that the USB, that the micro USB is on the side, just like it's labeled here. Put it in there, check it out, and then push it down. Okay, and then with the remove before flight pin inserted, we are ready for the testing in the next section.